Hi everyone, this is John, and in this video I'm going to be talking about controlling the DCO of the G2553 with push buttons and showing the output on this LCD and proving the labors of my work with this Pico technology USB PicoScope 3203D mixed signal oscilloscope, which I really like. All right, so let's get started. Let's flip on the switch. And as you'll notice, these very important numbers right here. Just kidding. Let's go ahead and fire up the USB PicoScope. Go ahead and start her up. And as you can see, let's talk about some values here. The F is the frequency, and these two values are right here are bit fields in the basic clock system register bits of the 2553. We have the RSEL, which I believe is the resistor select bits, and we have the DCO bits. And with these specific values, we have a frequency of 1 megahertz. And with our PicoScope, we have the current value. We have a minimum, a maximum, and an average value. Now, as you can see, the average value is that value that we're looking at, and it's a little different than the frequency that I have on the LCD. And what that is that the DCO is not a precise timepiece. It's not a crystal. It's not a quartz. If you want extremely accurate, precise timing from the G2553, you do not use the DCO. You use an external crystal or some other timekeeping instrument, because the DCO is not extremely precise and it fluctuates with temperature and all this other stuff. So on the day when I took this measurement, it was 1.072 megahertz, but today it's 1.068 megahertz. And what I did was I went through this before and I took all the averages and I wrote them down. I put them in the chip and I displayed them through the LCD. So I went through all these different values. And what values you say, John? Well, the R select and the DCO, like I said, these are 2-bit fields in the BCS control registers of the 2553. The R select goes from 0 to 15, and that's the major player in deciding the clock frequency. I'm going to go ahead and toggle those bits right now. The lowest, let's go to DCO 0. The lowest, let's get a couple of periods there to determine frequency. The lowest frequency we have with R select and DCO 0 is 91 kilohertz, and that's confirmed with the PicoScope, 91 kilohertz. And it's pretty awesome that you can control the frequencies on this 2553. I don't know how many other microcontrollers offer this kind of control over their frequency. It's pretty great. So the slowest you can get on this thing with the DCO, slowest you can get the DCO to go is 91 kilohertz. And you have R select 0, and as I said, it goes all the way up to R select 15. And R select 15 is 12.035 megahertz when I took it, and today it's 11.82. So R select 0 starts at 91 kilohertz. Let's go ahead and slowly step through, confirming them with the average value of our PicoScope. Select 1, 114, pretty good. 162, consistent. 3, 318, 446, 619, 877, 1.245, 1.794, 2.578, 3.262, 4.3, 6.0, 8.74, 11.82 versus 12, and then back to 91. So as you saw, those are the basic jumps in the R select, and most of them were pretty on, which was pretty nice. But as I said, some of them were a little bit off. The RSelect does the major jumps in the frequency. As you saw, the lowest 91 and the highest was 12, I believe. And the DCO does smaller increments of that. So DCO 0, 91, DCO 1, 97, 104, 111, 121, 131, 144, 160, and it goes up to DCO 7, and then back down to DCO 0. So the RSelect bits control the major jumps, the big jumps, and then the DCO control the smaller steps within those bigger jumps. So the slowest frequency we get, as you saw, was 91 kilohertz with the DCO on this bad boy. The fastest, RSelect 15, DCO 7 is 19.625 when I measured it. Today it's 19.53 megahertz. So even though the chip is spec'd at 16, you can actually get it up to 19 megahertz. And let's go ahead and zoom in and take a look at one of those, a couple of periods of that. Ooh, it's exciting. It's pretty neat. It's pretty nice. It's pretty nice. So let's go ahead and get something smaller. Let me go ahead and zoom out to get a couple of periods of this waveform to be able to average out a frequency. 233.9, 234, pretty good. So those are the basic bit fields that we can control to control the DCO, the main clock of the MSP430. So that was a lot of values, you know, 15 times 7, or 16 rather times 8. That's a lot of values. So I'm not going to do the math in my head because I don't want to. That's a lot of different values you can control using the RSelect bits and the DCO bits. But the 2553 doesn't stop there. It also has some calibrated frequencies. Excuse me. Let's go ahead and take a look at those. We have calibration 1 megahertz. And right there, you'll notice it's about the same, pretty good. And we have 4 different calibration values. So calibration 1 megahertz, 8 megahertz, pretty consistent. 12 megahertz, 11.94, not bad. 16 megahertz, 15.9898, still pretty good. So we have those 4 calibration values. And let's talk about some things that you might have noticed. The first thing is this new bit field called the modulation bit field. Now you ask yourself, well, what is that? And how come I didn't talk about it in the normal DCO control? Is it just a calibration value, or can I use it in DCO control? And the question is, you can use it in regular DCO control. The reason I didn't talk about it is because it just multiplies the complexity, and I just didn't feel like I got a little bit lazy, sorry to say, and I didn't take down all the values to be able to do the application, but I'm gonna go ahead and talk about it now. Now, to be able to talk about it, I'm gonna do some backstepping. We have the RSelect bits and the DCO bits. We have RSelect 6, DCO 6. Let's go back to normal frequency mode, go to RSelect 6, DCO 6. And as you notice, the frequency we get is 965, or rather 963. Where the calibrated frequency with RSelect 6, DCO 6 is 1 megahertz. The difference is the mod. And what the mod does is it breaks up the steps from the DCO into 32 different segments. And for 32 minus 13, we have 19. So for 19 of the segments, the DCO value is at 6. But for 13 of those segments, the DCO value is DCO plus 1, or DCO 7. So to go back to a regular, so the mod modulates between DCO 6 and DCO 7. And as you can see on the oscilloscope, that's kind of what we're seeing. Oops, let me go back. 6, 7, 6, 7, 6, 7, 6, 7. And that's that modulation that we see there. And so to talk about that modulation a little bit, I'm going to go over to persistence mode. And I'm not really going to really go over what persistence mode is. I'm just going to talk about the benefits of it. Now, as you can see, I'm sorry I took it a little bit long. Persistence mode shows us a basic color scheme right here of energy. The darker values are less energy, and the brighter values are more frequent, more energy, or values basically less energy, brighter values, more energy. And for our modulation, we can see we have a pretty broken up. We can't see too many patterns. We see some basic repetition, but if we go to our normal frequency, you can see some very obvious patterns of high energy, these very bright red areas right here. And the reason I mention energy is because a magnetic field is created with current flowing through wires, basically. And when you have this oscillator oscillating through wires going places, it's making basically a magnetic field. And if you have, as you can see right here, this is a pretty good one right here. You can see these energy values are very repetitious, and they're very high in these very specific places when you use the normal clock mode. So to break up that energy so that the magnetic field isn't so concentrated, that you can incorporate these modulation values. And when you incorporate the modulation values, the energy isn't so strongly pronounced in those specific places. It's more spread out. As you can see, we have some over here, some over there, but nothing extremely consistent. And that's what the modulation bits do. Let's go back to normal mode. So that was modulation. That was persistence mode, made possible through our lovely assistant here, the PicoScope 3203. That was DCO control. I'm John. That's the video. Hope you liked it. If you have any questions, leave them in the comments. I know it was fast and it was furious, and I know there was a lot of subject, but I hope you liked it. Have a good one.